AP Physics, this is summer lesson number 9 on force, mass, and acceleration. So what is force? Very simply, a force is a push or a pull. A force does not need to cause an object to move. So the units of measure for force in the metric system is called a Newton. The abbreviation for Newton is capital M. The abbreviation for force is capital F. So we see Stick Boy pushing with 5 newtons of force, and now there's an opposing force of 5 newtons. So do we know what the box is doing? Is it moving, not moving, accelerating, constant velocity? Well, we're going to find that out. So what is a force? Again, a force is a push or a pull. A force does not need to cause an object to move. So Stick Boy is pushing the box with 5 newtons of force. Does this mean that the box is moving? Does it have to be moving? The answer is no. If there's a 5 Newton force pushing back against Stick Boy, then the box is not moving, or it's moving at a constant velocity. So the 5 newtons to the right and 5 newtons to the left is called a balanced force, and in that case you don't know whether the box is not moving or whether it's moving at a constant velocity. What you do know is the box cannot be accelerating, that is, changing velocity. So if the forces in opposing directions are equal, we say they are balanced. So again, we see 5 newtons to the right and 5 newtons to the left. If the forces on an object are balanced, then the object is either 1, not moving, or 2, moving at a steady velocity. And when you think about it, not moving is moving at a steady velocity. It's a velocity of 0 meters per second. Now I put this one as tricky because it would be apparent that the box wouldn't be moving if the forces are balanced, but it can be moving and moving at a steady velocity if the forces are balanced. So if the forces in both directions are not equal, we say they are unbalanced. Okay, so now we have 5 newtons to the right and 2 newtons back to the left. If the forces on an object are not balanced, then the object is accelerating. That's the only state of motion it can have. Accelerating, remember, could mean a number of things. It's speeding up, it's slowing down, or it's changing direction. Forces are vectors. Forces can be added. So Stick Boy pushes with 10 newtons of force and Stick Girl pulls with 5 newtons of force in the same direction. Then the total force on the box is 10 plus 5, and that's going to equal 15 newtons. In this example, 15 newtons is called the net force. A net force is what you get when you add or subtract 2 or more forces. So just like velocity and acceleration, forces are vectors. They have a specific direction to them. Forces can be subtracted. If Stick Boy pushes with 10 newtons of force and Stick Girl pushes in the opposite direction with 6 newtons of force, then the total force on the box is 10 minus 6, which equals 4 newtons, and it's to the right. It's in the direction of the bigger of the 2 forces. What is a free body diagram? A free body diagram uses a simple box to represent the net forces on an object. So these forces are balanced. So you have a 5 to the right and 5 to the left. You have a 3 up and a 3 down. Now it doesn't matter that the 3 up and down are a different number than the 5 right and left. It's that the opposing forces have to be the same. So 5 and 5 are opposing and the 3 up and 3 down are opposing. So those are balanced forces. Now the free body diagram doesn't have to be a box, but it uses a box. It could represent a car, it could represent a book, it could represent a body, somebody's body. It's the forces on some object. It's just a box is used to simplify the illustration. Forces are balanced when all opposing forces are equal. The object is either standing still or moving at a constant velocity, and we don't know which direction it would be moving if it is moving. Only the forces on opposite sides of the box must be the same for the forces to be balanced. Forces are unbalanced when any opposing forces are not equal. So that object must be accelerating. So the three up and down are balanced. So it is not accelerating up and down, although it could be moving up or down at a constant velocity. But the forces left and right are unbalanced. That means it is accelerating to the right. But that's a little tricky. It doesn't mean that the box is necessarily moving to the right. We'll talk about that in a minute. So force equals mass times acceleration. The formula is F equals ma, where F is force, m is mass measured in kilograms, and a is acceleration measured in meters per second per second. The system is called the kilogram meter second system because those are the base units of mass, distance, and time that are used in the system. So what is a Newton? A Newton is the metric unit measurement of force. 1 Newton equals 1 kilogram times 1 meter per second squared. So that's force for newtons, mass is in kilograms, and acceleration is in meters per second squared. Notice that this follows the equation F equals ma. So a Newton is the amount of force that it takes to accelerate a 1 kilogram mass at 1 meter per second per second. How much force is required to accelerate a 4 kilogram cart at 5 meters per second per second? So you just break down the format, just use problem solving format. F equals question mark, m equals 4 kilograms, a equals 5 meters per second per second. That leads you to the formula F equals ma. Plug in the numbers and you get 20 newtons of force. And that takes care of this brief lesson on force, mass, and acceleration. And we will use this throughout the course.